Hello and welcome back to RC Model Reviews. Today I'm looking at this. It's the Turnigy thrust measuring stand. And what is it? Well, it's a simple device. It enables you to mount a motor on here with a propeller, drive it with your favorite ESC and battery, and then the thrust generated by that combination of battery, ESC, motor and propeller will appear on this lovely little screen down here. And if I turn it on, you can see, ooh, it even has a little backlight and it measures in grams or ounces. There's a few other features and things there. So yeah, it's really a fairly simple setup, but it's one that can be incredibly valuable when you're trying to get the best performance out of the components you've got at hand. And of course the unit comes with a single page of instructions, only written on one side, there you go. But I mean, it's the basics. Strangely enough, it does say that it does not come with batteries, but it doesn't tell you how to put any batteries in it. So it's a trap for young players. And what sort of batteries does it take? But fortunately, it just requires the removal of 4 screws, and inside there is a little AA battery holder. I actually put AAAs in because that's all I had. Now, construction quality wise, well, let's look at the electronics first. It's got this, remember I did a tear down of some scales recently, just some my horrible Chinese scales of hell, you know, and pretty much the same things here as it was in those scales. We've got a little circuit board here, and it's got that little black blob is just a blob of epoxy, because underneath there's an integrated circuit which is actually mounted directly on the board. It's called a chip-on-board solution, which makes it very, very cheap to manufacture because there aren't all sorts of soldering stuff to be done. There's wires. Fortunately, the wires have been supported by some of this sort of, looks like contact adhesive sort of gunky stuff here, so they're not going to break off at the board. But yeah, even then, this is a very low cost solution to the problem. Over the side here there are some soldered wires. There's no insulation or support on these wires here, which is unfortunate because, you know, they're pretty thin wires, and vibration, who knows, because let's face it, you can have a motor on here, there could be quite a bit of vibration because the prop may not be balanced. Who knows what could go on. So now let's take a look at the mechanics of this device. It's reasonably well put together, actually. I mean, it's all nicely blue anodized aluminium. I believe that if you order it in America, it actually comes with blue anodized aluminum rather than aluminium. I don't know, actually, is it anodized? Yeah, it looks anodized. So yeah, it's a nice, you know, pretty looking unit. And there's a spare motor mount here, spare motor mounting plate, because it will work over quite a range of different motor sizes. So for the big motors, you use this plate to replace this little one up here. Yeah, that's all well and good. Now, once you've mounted your motor on this plate on the front here, this little platform can move backwards and forwards, and as it does, it pushes on this. This is what we call a load cell. I mentioned this in the scales teardown, and the load cell has some wires coming out of it, which goes off to that electronics we saw before. Now, here we have some linear bearings, which are basically, well, they've called them tube bearings in the instructions, but they're commonly known as a linear bearing, which has a very little friction sliding backwards and forwards. And so this little stand is free to move. It will only work, by the look of it, in tractor mode, which means when you've actually got the propeller pulling things this way, heading, so it's going to have a tractor prop on there, which is a shame because I wanted to show the difference between running a motor and tractor in forward mode, but never mind. Yeah, there's a few buttons here to do a few different things. We'll have a look at those when I get it fired up. It's got some holes for bolting to a bench, because let's face it, I think this thing can handle, it doesn't say in the instructions, does it? Yes, it does. It will handle maximum thrust of 5 kilograms. So you wouldn't want to leave this just sitting on the bench. It'll probably take off and fall on the floor. So we'll have to bolt it to something or use a clamp or something to hold it down. Now, one thing I'd like to have seen on this, but it's not a big deal, is when you're measuring thrust and things, you generally want to work out the efficiency as well. Some combinations of motors, props and ESCs are far more efficient than others, but to work out the efficiency you need to know the amount of current that's being drawn. Now we've got this lovely little LCD here with the little blue backlight. Wouldn't it be nice if that also was able to measure the current, and then perhaps the voltage, and then work with the scale here to give us an efficiency figure? I mean, yeah, it'd be a nicely integrated solution. I mean, this is reasonably cheap, but imagine a deluxe version that did all that work for you, because otherwise you're going to have to sit down with a pencil and paper and a calculator and work out these things if they're important to you. So without further ado, let's get to it. Let's mount a motor on this baby, fire it up and see if it works. So I've set the motor up on the test stand. I've got a watt meter here which will measure the power going into the motor. I've got a little ESC. This is a mini quad motor, of course. So I've used a 12 amp Afro ESC here, which is probably about right. I'm going to do some really interesting tests later on, because a lot of people aren't aware, or they don't know what effect a speed controller has on the power a motor can produce. Now, if we use a 12 amp speed controller, we're going to get a certain amount of thrust. What if you used a 100 amp speed controller? Would you get more power out of that motor? Well, it's something interesting that we'll be finding out in a later video, but let's just see if this thing works And so, as I say, I've got the motor, I've got the ESC, I've got a little servo controller, a little servo adjuster thing here to make the throttle go up and down. Got my watt meter, got a battery. Let's plug it all together and see what happens. Right, power on. The usual ESC noise you're so familiar with. And okay, we've got this on watt meter, so I'll select enter. Here we go, and now it tells us currently we're drawing just 0.2 amps. And we've got 11.3 volts in that battery. That's 2.2 watts just going into doing nothing. Well, it's actually running the little beacon there, which provides power for the servo controller, the little servo adjuster thing, and also obviously the computer on board, the ESC there. So let's start cranking this baby up. I haven't bolted it to my bench, as you can see, so I'm going to have to hold it down as I crank up the power, and hopefully not too much stuff's going to get blown around. It's a bit awkward at the moment because I have to come around the back of the camera and reach through the cable and hold this here as I wind up the throttle. So here we go. We're now drawing 4.5 watts with 20 grams of thrust. Let's just see what we get out of this baby. We had 81 watts and 330 something grams of thrust, which is, it's what you expect for one of these little 1806 mini quad motors driving a Gemfan 5.3 propeller on a, LiPo battery that's not fully charged. So yeah, I'm pretty happy with that. This little thrust stand seems to work. It is easy to use, doesn't take much setting up. I'll have to bolt it to the bench, but apart from that, I'm going to use this actually when I'm doing my mini quad motor shootout. But of course, remember, you could use this with any electric motor, any brushless outrunner that produces or is going to produce less than 5 kilograms of thrust. So, for your fixed wing, for whatever, if you've got a plane and you really want to just work out the best combination of props, because, okay, we've just shown that. I've got the Gemfan 5.3. I'm going to change that prop and we'll see what happens. So here we go. I've replaced the Gemfan 5x3 prop with the Gemfan 5x4. Same battery. Let's just see what we get in the way of thrust this time. As I hold it down, I hope the workshop doesn't blow away. Well, actually not a lot more thrust really. There was 340 something versus 330 something. But the power went up to well over 100 watts. So this produces more thrust, but my goodness, it's going to suck your batteries dry because it's far less efficient. And that's actually a very important thing. So you'd know if you're running a mini quad, if you change from the Gemfan 5.3s with this particular motor and ESC, then you're going to get shorter run times. You get a little bit more power, but shorter run times. So these are the things that you use a test stand for. You can work this out. Do you really want a mini quad, for example, that will go for longer but has less punch, or do you want to have full punch at any cost? Great stuff you can figure out with your little watt meter and your test stand. Actually, I noticed the tier's drifting. It's going into -3. It might be these leads. I hope this isn't going to be the test stand from hell like my Chinese scales. I think it was probably just these leads. In fact, that may have had an effect. I noticed the prop was probably blowing this back. Yeah. One thing I would like to see is a better arrangement, because at the moment, of course, any movement on this wires here are going to cause an effect on the stand. It'd be nice if there was some better way of doing that. Now, I should run longer wires here, but I just used what I had available just to test this thing out. I'm going to set this up far more elaborately for the mini quad motor shootout. But as I said just a moment ago, you can use this to test any motor, although you're going to have to hang it over the edge of a bench, because once you get to about 7 inches of pitch, or 7 inches of diameter, it's going to start gouging holes in your bench otherwise, but that's not a big deal. You will mount this over the edge of a bench. Yeah, brilliant. Well, I'd have to say on my initial look at this thing, after having had a little play with it, it's for the money, it's actually not a bad bit of kit. Really, it's not a bad bit of kit. It's not perfect. Nothing's perfect in this world, but it could save you a lot of time messing around trying to build your own test stand. It just seems to work. It's easy to use. Once you work out how to open this take this little top plate off, rather than the back or the sides, you can put the batteries in easy enough. And yeah, I'm going to give this one a thumbs up. Nice product. I'm happy with it. There are some little issues. I'll show you what I mean. Let me tip this up. I noticed that the slide bearings are not completely aligned with the plate, so they're actually at a bit of an angle. You see how the bearing is actually canted this way and the plate straight. These are little things. This isn't a precision instrument. This is going to be something that will give you good relative measurements. And I mean, again, it's now, oh yeah, that's all right. It's just the forward motion on those wires was upsetting the load cell. Now it's got 8 grams of preload. Ooh. Anyway, yeah, thumbs up. That's enough. Rambling on. If you've got comments, if you've got questions on this little test stand and the review I've done, put them in the space below the description of this video that's been kindly provided by the people at YouTube, and I'll do my best to address them or answer them. In the meantime, thank you for watching. I'll have to clear this off so I can get back to my bench. Bye for now.